All right, lesson 4:1. So chapter 4, lesson 1. Getting into chapter 4, it's about writing linear equations. So we're staying with linear equations. It should be pretty easy. And this section is great because it's writing linear equations in slope-intercept form. So you already know slope-intercept form. You know what linear equations are, so this should be relatively easy for you. So we're going to start with some warm-up exercises just to remind you, and you just took a test on this. So find the slope of the line that passes through the point. So I'm going to let you go ahead and work those, bring those done to class. Just practice those. They're on your paper. And I'll go through that really quickly. The warm-up exercise number 3 is a good warm-up word problem. A landscape architect charges $75 for a consulting fee and then $30 per hour. So write an equation that shows the cost that you would pay him as a function of time. So think about that what he charges as a constant, just $75 just to come talk to you, and then $30 for every hour he spends with you. So you would have to write an equation of cost being your y. The total cost depends upon how many hours he works. So you write that, and then we're going to go on. So I know you can stop the video and watch that, but just hopefully you got that right. So here's our first example, okay? We're going to use slope and y-intercept to write an equation, and this is very simple. It just says write an equation of the line with a slope of -2 and a y-intercept of 5, okay? So here we go. We obviously would know that slope-intercept form is y equals mx plus b, where m is your slope and b is your y-intercept. Well, they give us the actual terms, so we're just going to substitute those in. If our slope is -2, that goes in for our m, and 5 would go in for our b. So we just technically just do that. Y equals -2 slope, and y-intercept is +5. So we keep that plus because it's a +5 y-intercept. Okay? That's all there is to example 1. Easy peasy. Example 2. Which equation represents the line shown? Okay, again, what do we know in this picture? Well, first of all, we can tell the point that it crosses the y-axis. So we know the y-intercept is right there. So there's our y-intercept. We also know our slope. We can see our change in y, and we can see our change in x. So that's what we already know by even looking at that picture. So which one of these equations shows a y-intercept of 3? Well, this one definitely does not. And this one has a y-intercept of 2/5, so that one does not. So it has to be one of A or B. It has to be one of those two. Well, my slope, my change in y is -2, and my change in x is +5. So my slope is -2/5. So obviously then A is my correct answer because we just substitute my y-intercept and substitute in my slope. And it says the slope of the line is your rise over your run, and they show you there the same thing I just showed you. So, and the line crosses the y-axis at 0, 3, so the y-intercept is 3. So therefore, we substitute those values in, and there's our equation. So that's why A is the right answer. Okay, so the correct answer is A. Yay! Okay, on example 2, it doesn't talk about counting, but that's what you're doing, counting and going over. So that's example 3, same idea. Okay, we're given 2 points. Okay, one of those is the y-intercept. Okay, it says to calculate the slope. That is one of your options. You can calculate the slope because this is a very important formula to know. Okay, so if you need practice with that, you can calculate the slope. However, if you're given the picture, we can also calculate the slope this way. If you're given the graph, we can start at our y-intercept and we can go up 1, 2, 3, 4. So my change in y is 4, and then my change in x is 3. So my slope is going to be 4/3. So let's see if that's what they figured out with the slope or with the slope formula. Yes, 4/3. Okay? So you can do that either way, and that's what it says on your paper. that you can calculate the slope. You can count between points, or you can use the slope formula. And then write an equation of the line. It's obviously on the graph, we see the line crosses the x-axis, the y-axis, crosses the y-axis at 0, -5. So the y-intercept is -5. So let's substitute those in. And 4/3 is my slope. And this time, notice my plus b becomes a -5 because my y-intercept is negative. So I don't write plus and -5. I just write 4/3 x -5 because that represents a -5. Okay? All right, so fairly easy so far, I think. All right, let's get into some functions. Writing a linear function. Just remember, there's no difference except that we now have f of x equals whatever. Linear with f. Okay, so we're just using our f of x instead of our y. Write an equation for the linear function f with the values f of 0 equals 5 and f of 4 equals 17. So again, remember the f of x is your y value. So here is your y value. Okay? And obviously, there's your x value. So here is our x value. Okay, just keep that in mind. The x is in the parentheses. The y is over here. So notice where your variables are. There's your x, and there's your y. So keep that in mind. So now we know we have the points that are obviously right there. We have a point 0, 5. Okay, so write f of 0 equals 5 as 0, 5 because, again, we said here's x. So there's x. I should have done it in red. Sorry. Let's erase that. And because my x's were in red. So here's my x value, and here's an x value. Okay, and here's my y value, and here is a y value. So we write that as a point, and we talked about this last chapter. X, y. These are coordinate points for this function. That's even though we don't even have a function there, we know these are coordinate points on a function. Okay, same thing over here. Here is my x inside the parentheses, so that becomes my x coordinate. And here is my y, so that becomes my y coordinate. So now look what we have. We have 2 points. We can find the slope between those points using slope formula. We also have the y-intercept because we have the 0 of x, or the 0 for our x, and our 5 for y. That would be our y-intercept. So we're going to find our slope. Okay, so y sub 2 is 17, and 17 minus 5 is 12, and x sub 2 is 4, and 4 minus 0 is 4. So my slope is 12 over 4, and 12 divided by 4 is 3. So there's my slope. My y-intercept is 5. So now I can write the equation. It says write an equation of the line. The line crosses the y-axis here, so the y-intercept is 5. So again, there's my slope-intercept form, and I just substitute in those values. Okay? Use these examples, please, for your guided practice. So here's my actual function. Notice all they did was change out the y for the f of x from the original problem, where it says write an equation for the linear function f with those values. Okay, so my f of x equals 3x plus 5, and they just copy this part down. Okay, so they just trade out the f of x and the y. They just exchange them out. So this is an equation. This is a function. This kind of different terminology. All right, example 5. This is the last one, and then you can do your guided practice. A recording studio charges musicians an initial fee of $50 to record an album. Studio time costs an additional $35 per hour. So initial fee is what's not going to change. That is my constant. You're paying that just to secure the studio. Then you're paying $35 per hour to be in the studio. Okay? Write an equation that gives you the total cost of an album as a function of studio time in hours. Okay? And then B, find the total cost of recording an album that takes 10 hours. So we're just going to plug in 10 for X and find our cost when we finally get our equation. So the first thing we have to do is identify the rate of change and the starting value. So the rate of change is M. That's our cost per hour. That's what changes. Our cost is going to change depending upon the number of hours. Okay? So our starting value is our B, which that's our initial fee. That's what's not going to change. We're paying that whether we use 0 hours or 100 hours. We are paying that initial fee, okay, of $50. So here's kind of a verbal model if you want to. This is a good way to always kind of start and think of it like this. Our total cost equals our cost per hour times the number of hours you're in the studio plus that initial down payment just to secure the studio. So there's kind of an idea. And then we can substitute values in. Our total cost is C. Our cost per hour, well, we know that's $35. And then that's what we don't know, the studio time. We don't know how many hours it might take us to record our album. If it's me, it's going to take me lots of hours because I stink at music. So then T for our studio time in hours plus the constant in this, which is $50. That part will never change. This part may change depending on if you spend 1 hour or 10 hours. Okay? So the total cost C is given by this function. C equals 35T plus 50. Now for part B, how much is it going to cost for 10 hours of studio time? So just simply substitute that in. At 10 hours, for 10 hours at $35 an hour, you're going to be paying $350 plus the $50 studio fee, so the cost would be $400. $350 for the hourly cost plus the $50 initial fee, $400. All right, you can stop there and do your guided practice.